We know that a quadratic equation looks like ax squared plus bx plus c equals 0, where a, b, and c are real numbers and is not equal to 0. The key idea of solving by factorization is to express the quadratic as a product of two linear factors. For example, x squared minus 3x plus 2 equals 0 can be written as open bracket x minus 1 close bracket into open bracket x minus 2 close bracket equals 0. Now, once we get this product, we use a very powerful property called the zero product rule. Here's the rule. If a multiplied by b equals 0, then either a equals 0 or b equals 0. This is the magic that helps us solve factored quadratics. Take our example, open bracket x minus 1 close bracket into open bracket x minus 2 close bracket equals 0. According to the rule, times either x minus 1 equals 0, which gives x is equal to 1, times or x minus 2 equals 0, which gives x is equal to 2. So the solutions of x squared minus 3x plus 2 equals 0 are 1 and 2. Now let's turn this into a method, a neat checklist. 1. Step 1. Write the quadratic in standard form ax squared plus bx plus c equals 0. To step 2. Factorize the left-hand side into product of two linear factors. 3. Step 3. Equate each factor separately to 0. 4. Step 4. Solve each resulting linear equation. 5. And finally, verify your solutions by substituting them back into the original quadratic. This method ensures that the roots are correct and no false solutions sneak in. Let's apply this method again to x squared minus 3x plus 2 equals 0. Step 1. It is already in standard form. Step 2. Factorize to get open bracket x minus 1 close bracket into open bracket x minus 2 close bracket equals 0. Step 3. Apply zero product rule. So either x minus 1 equals 0 giving x is equal to 1, or x minus 2 equals 0 giving x is equal to 2. Step 4. Substitute back. For x is equal to 1, 1 squared minus 3 times 1 plus 2 is equal to 1 minus 3 plus 2 is equal to 0. Heavy checkmark valid root. For x is equal to 2 squared minus 3 times 2 plus 2 is equal to 4 minus 6 plus 2 is equal to 0. Heavy checkmark also valid. So the verified solutions are 1 and 2. Now here's something important. Always check your solutions by putting them back into the original quadratic. Why? Because mistakes in factorization can happen. If the substitution doesn't give 0, then it is not a valid solution. And sometimes equations don't factorize neatly into integers. In such cases, we need other methods like completing the square or the quadratic formula. But whenever factorization works, it's the simplest and fastest method. Let's try a tougher one. 2x squared minus 5x plus 3 equals 0. Step 1. Multiply a and c. Here, a is equal to 2 and c is equal to 3. So a times c is equal to 6. We need two numbers whose product is 6 and sum is 5. That's 2 and 3. Step 2. Split the middle term. So we rewrite as 2x squared minus 2x minus 3x plus 3 equals 0. Step 3. Group terms. Take 2x squared minus 2x and 3x plus 3. Step 4. Factor each group. That gives 2x open bracket x minus 1 close bracket minus 3 open bracket x minus 1 close bracket equals 0. Step 5. Take common factor. We get open bracket 2x minus 3 close bracket into open bracket x minus 1 close bracket equals 0. Step 6. Solve each factor. Times 2x minus 3 equals 0, x is equal to 3 divided by 2. Times x minus 1 equals 0, x is equal to 1. So the roots are 3 by 2 and 1. So let's wrap up. Times factorization means breaking the quadratic into two linear factors. Times the zero product rule tells us that if a product equals 0, then one factor must be 0. Times the method is write in standard form, factorize, equate each factor to 0, solve, and verify. Times it's the quickest method when the quadratic splits nicely. Times, and as we saw, even tougher quadratics can be handled by splitting the middle term carefully. That's the beauty of solving quadratics by factorization. In the next session, we'll look at other methods like completing the square, which work even when factorization is tricky.